Hello everyone, welcome back to my channel. By the way, you should watch first my two previous videos about circle symmetric property before answering this exercise 11B of Xingli New Syllabus Mathematics 7th edition. Before we proceed, let's recall first two important theorems needed for this exercise: the exterior angle theorem and the isosceles triangle theorem. An exterior angle is formed by extending one of the sides of a triangle. In this particular example here, x is the exterior angle. Angles A and B are interior angles. We can also have another interior angle here, which is, say, angle C degrees. But C is adjacent to x, and angles A and B are remote interior angles. Exterior angle theorem says that the measure of the exterior angle is just equal to the sum of the two remote interior angles. In short, x is equal to a plus b. This is the exterior angle theorem. Again, exterior angle, the sum, or I mean the measure of the exterior angle is just equal to the sum of the two remote interior angles. Simply x is equal to a plus b. That's exterior angle theorem. Isosceles triangle theorem. Isosceles in the sense that two sides are given to be equal. Say this measures a and this measures a. It says that if two sides are equal, the angles opposite to these two sides must also be equal. So if this measures b degrees, the other angle must be or must have the same measure. Okay? So again, isosceles triangle theorem says that if the two sides are given to be equal, then the angles opposite to these two sides must also be equal. Let's solve some items here. I'm going to solve some items of this exercise 11B, and then the rest you will do them. Okay. Let's start with number one. Number one. Let's do number one. Okay. In the figure, BP is tangent to the circle with center O. Given that angle APO is 33 degrees, find the measure of angle PBA. In this particular diagram, we know that we can see two radii here. Okay? And all radii of a circle are equal. So these two sides are equal. AC and PO, AO and PO are equal in length. Okay, so by isosceles triangle theorem, because these two sides are equal, thus we have this isosceles triangle. AOP is an isosceles triangle. By isosceles triangle theorem, if these two sides are equal, then the angles opposite to these two sides must also be equal. Thus, the measure of angle PAO is also 33 degrees. Now the radius and a tangent are perpendicular. They are always perpendicular. A radius OP and a tangent BP are perpendicular, thus creating a 90-degree angle. Okay. Now we have this triangle. If you look at this triangle, this blue triangle, we are asked of this angle here. Okay, and the sum of the three angles of any triangle is 180 degrees. So we can solve for angle PBA. Okay, the measure of angle PBA, this is just equal to 180 minus 33, this one, minus 33, this one, and minus 90, this one, which is equal to 24 degrees. Okay, 180 minus 33 minus 33 minus 90 is 24. Okay. What else? Let's solve number 3. Let's do number 3. Okay. And the figure AB is a tangent to the circle with center O. D is the midpoint of the chord, and then the chord BC. And given that the angle BAC is X, find the measure of angle COD in terms of X. Okay. We know that we have a triangle here, right triangle. This is a right triangle. So this angle X and this 90 degrees here, this is just the R remote interior angles of this exterior angle Y. Okay, you're going to extend this one. Y will be the exterior angle of this right triangle OAB. Okay, and by exterior angle theorem, the measure of the exterior angle is just equal to the sum of the two remote interior angles, X plus 90. Okay. Now, solving for COD, angle Y is just being divided into 2 to solve for COD. So COD here is this one. This is just equal to Y over 2. Okay, that angle is being bisected because this one is BC is a chord. Okay, BC is a chord, and then these two sides are equal, plus the fact that this line from the center is perpendicular to the chord CB. Thus, this angle is bisected. Okay, so therefore, angle COD is just equal to our Y is X plus 90. X plus 90 divided by 2. So therefore, our angle COD is X over 2 plus 45 degrees. Okay. So this is the measure of angle COD in terms of X. What else? Okay, say number 4. Let's do number 4A. Let's just solve one item here as an example for this part. Okay, number 4A. Given that PA and PB are tangent to each of the following circles with center O, find the values of the unknowns. Okay. PB and PA are tangents. Okay. And therefore they are equal because they are coming from the same external point P. So these two sides are equal. So B is equal to 14. Okay. Now this line here coming from the center to an external point P, this is actually a bisector, an angle bisector at the same time. This is an angle bisector. This line here, OP, bisects the angle BPA and angle BOA. And so therefore, A is also equal to 49. Okay? A is also 49. They are equal. This angle and this angle are just congruent. So A is 49. We can also solve C. We'll just solve C here. Okay. So these two sides are equal. This one, because they are tangents from the same external point, from an external point P. And this OP bisects the angle So 112 divided by 2, so this angle measures 56 degrees. Also this measures 56 degrees. Now we have right OB and BP are perpendicular, so that's creating 90-degree angle. So we can solve for F now because we have right triangle. Okay, and this involves SOHCAHTOA, and we are going to use tangent ratio because we have 56 here okay, plus the adjacent side 10 and then the opposite. Okay, so we'll use tangent ratio. So tangent 56, this is equal to opposite, which is F over adjacent, which is 10. Okay, so there our F is equal to tangent 56, or 10 multiplied by tangent 56. Okay, your calculator must be in degree mode. You should have an answer that is 14.8. This is to 3 significant figures. Okay, 14.8 to 3 significant figures. Okay. What else? Okay, let's try to solve number 6. Let's do number 6. Okay, I'll give the rest to you. Number 6. The figure shows a circle center O. AC is a tangent to the circle at A and OBC is a straight line. Given that AC is 18 centimeters, as you can see in the figure, and BC is 12 centimeters, find the radius of the circle, the measure of angle AOB, and the area of the shaded region. Okay, let's do this. So we let R be the radius. This is the radius. OA is a radius and AC is a tangent, thus creating 90-degree angle here. A radius and a tangent are perpendicular lines. They always create 90-degree angle. So we can use a Pythagorean theorem here, which says that the square of the hypotenuse, okay, the square of the hypotenuse is equal to the sum of the squares of the two other sides. So C squared is equal to A squared plus B squared. Using the this theorem, so we solve the first question. Our hypotenuse is OC, so R plus 12 squared. This is equal to R squared plus 18 squared. Okay, expanding R plus 12 squared, this is R squared plus 24R plus 144, which is equal to R squared plus 18 squared is 324. Subtracting R squared from both sides of the equation, this R squared will be cancelled, leaving us 24R, which is equal to 324 minus 144. Okay, so 24R is equal to, this is 180. Okay, so R is equal to 180 over 24, giving us an answer of 7.5. Okay, so our radius is 7.5 centimeters. Okay, we're now going to solve for AOB. Okay, AOB. We let AOB to be theta. In reference to theta, we have radius and the opposite, which is 18. So we can use tangent ratio. So tangent theta is equal to opposite over adjacent. So this is 18 over r, our radius, which is 7.5. Okay, so our theta is 18. Okay, so using your calculator, you should have, we can get 67.4 to 1 decimal place. Okay, to 1 decimal place. This is the measure of angle AOC. Okay, now solving for the area. Area of the shaded region. This is for the next question. Area of the shaded region. This is just equal to the area of the triangle. Area of the triangle, which is the right triangle, minus the area of the sector. Okay, so area, the area of the triangle is base times height divided by 2, so 7.5. 7.5 times 18 divided by 2 minus the area of the sector, which is 67.4. 67.4 being part of the circle. So divided by 360 times pi r squared. Okay, the radius is 7.5 squared. Okay. Okay. Our area must be 34.4 centimeters squared. This is the area of the shaded region. Okay. Okay, you can now do the rest of the questions. Anyway, you can always refer to the answers here. There are answers here at the bottom part. Okay. So you do the rest. Do the rest of the questions. Okay. Do number 2. Okay. Number 4B. Number 4D. Number 5. Number 7, 8, 9, 10, 11, and 12. Okay. Thank you.